So the landscape where connection profile gets used is really about physical assets. So these are physical assets, everything from sensors to SaaS service and processes and buildings and all other assets. And the concept here is that what we're doing is we're creating a digital fabric, right? Which is really the twin. And the digital fabric here is made up of nodes, these blue dots, and connections, which are the lines between them. Each of the blue dots is a virtual representation of one of these physical assets, right? And the lines are connecting these dots for a specific purpose, right? And so the organization of this digital fabric is done for a specific purpose, right? So there's kind of a logic behind it, the gears here. And it's normally for the purposes of our consumption or the consumption of robots down the road. Right? So this is kind of the way we think about a connection profile and digital twin. This digital fabric really is what a lot of people talk about system of systems, right? So there's really two types of systems here. There's the host system that is actually aggregating all of the blue dots. And then each of the blue dots is a virtual representation of some subsystem, right? In this case, this air conditioning compressor. So each of the dots is really a sort of a virtual interface of how this subsystem is being consumed by this host system, right? So it has information. If you expand this blue dot, it has information about the host, how it fits in the host and what its role is. And it has information about the subsystem, what it is, where it is, URI, etc., etc. And the purpose of doing this is to create a mechanism so that this blue dot, representing the actual subsystem, can consume information and can serve information to other entities. What other entities? Other blue dots, right? So each of these lines is a connection that on one end there's a consumer and the other end there's a server, there's a producer, right? So if you take this connection between L and K, right? So that is an instance of a connection profile. And the way connection profile sort of does this is that the connection profile itself is a template for how connections are going to be instantiated between nodes, right? So in this case, the L is a client and K is the server, right? And it's using the connection profile of this name, proto.example.sys, right? So it creates an instance based on this template, so the two ends know exactly what it's supposed to be doing, right? And I'll go into a little bit more detail about how this works. So this is the mechanism of connection profile. So what's interesting is sort of thinking about what these systems are, what these systems could be, right? So if we think of existing systems that we know today, right? Everything from facility management to BIM systems and HVAC controls and whatever, right? If you sort of think about what's actually behind them, they're objects, right? They're fans in this case of the HVAC, they're pumps, and in the FM, it's whatever it is, rooms and whatever, right? So essentially the way you overlay this digital fabric is you literally overlay it. Right? So you have a digital fabric that can sort of be overlaid on top of any of these existing systems, where each node is actually representing some object in that system, right? So this is a twin of the control system, and obviously this node is representing this pump and motor. And all of the connections between these blue dots is, as we described in the previous slide, is kind of using connection profile. So what this enables people to do is not only to connect entities within a system, but also then connect entities across systems, right? Because these thicker blue lines are exactly the same as the thinner blue lines, right? So they're using connection profiles across systems. And the mechanism is identical, is the same, right? So it really works really well for that. The other way to think about it is the integration kind of use case, where you have the sort of the fabric that's not actually representing each of these as I did in the previous slide, but it's actually its own sort of thing, And this is in fact what paddy.io does, right? So it's a generalized sort of application. But the mechanism of connection profile and instantiating these blue dots being virtual interfaces still is the same. So what you can see here is that this air handling unit, which is actually this dot, is actually obviously in this building, and this chart is obviously in the building, etc., right? So this is kind of how you start to connect things together. The other sort of really interesting concept in digital twin is the concept of digital threads, and connection profiles really work well with digital thread. This is sort of a depiction of it. So if you think of a digital thread, usually the way to think about digital thread is a digital thread about something, right? So think about X being, let's say, a boiler, right? That is in a building, right? So that boiler exists at the design phase, right? It physically probably doesn't exist, right? But it exists in some tool that A is using, or the tool A is the tool that's using it. So A has a connection profile to X, to the boiler, and so does P, is kind of the corporate owner, let's say, of the boiler. But as it sort of goes down its sort of timeline, it goes into a design BIM, in which case this is the BIM system that's created another connection instance here. As it moves into creating a bill of materials, maybe at this point X is not just a virtual boiler, it actually becomes a boiler of a specific brand, right? So that is then known by this connection between G. As it gets installed, then you may actually have the serial number of BIM and other sort of attributes in real life, right? It may change owners, and it may have an insurance connection or other sort of connections. And as it goes into the sort of the operation cycle all the way to facilities management, you still have the same boiler, right? And it has all of the connection profile to N, which will be let's say, the facility management system. But it also has all of its historical connections all the way back to the design, right? Mm-hmm. And they're all established using connection profiles that are probably different from each other. All of these connection profiles are going to be different profiles, right? But N could interrogate X, and X would know about its complete history without N having to know what A or B or G or anything is, right? It's all sort of coordinated here. And each of these connections are connection instances based on a profile, right? So it creates a hugely sort of dynamic and sort of long-lasting way of tracking and sort of managing entities.
Sorry to interject, you use the term digital fabric, and then we went down into the digital thread. So can you just give a quick distinction between the two? What do you meant by digital fabric? And now here you've given us a more detailed view of the digital thread. Is the digital thread part of that digital fabric you mentioned?
If you think of fabric, right, just the word fabric or any sort of fabric entity, it's made up of threads, right? Generally in sort of blankets and stuff, the threads go in two directions, right?
Yeah.
In digital twins, the threads go in all over the place, and it's three-dimensional and it's very complex, right? So there are threads, and this is really sort of what this is depicting, is there is a thread in time of X, but really what's being created here is a fabric of X. But obviously X is not alone, right? X probably has other devices or products connected to the boiler, fans and pumps and pipes and whatever. So that becomes sort of another dimension of this. That's starting to create the fabric. So digital thread is really sort of one-dimensional sort of view, although that's strictly speaking not correct because it's kind of odd, but it's kind of a one temporal dimension through of a particular entity that's all connected to everything else, right? And obviously all of these entities across the top, A is not just connected to this particular boiler, it's connected to the other entities in that particular product and or asset or whatever, and so is the same. So this is kind of just a thread is just one view through the fabric.
Yes, that makes a lot of sense, actually. It's nice how you can explain it in those conceptual ways, because we often hear a lot about digital threads, but to visualize it and to really show that it is kind of akin to a thread, which is part of a larger network, which you could say is the digital fabric.
Yeah, yeah, and we often use the term that Paddy, which our product that does this, we're actually a loom, right? We're making these threads. Just to continue the analogy.
Yeah. Okay, great.
So just sort of one other thing, if it's so go a little bit deeper on these lines, right? The instances. So to explain a little bit about how it works. So we start off with an instance. So this is kind of going backwards in time. An instance, as I mentioned earlier, is based on a profile, right? So you're going to have a profile. A profile essentially has information about what a server or what one end, which we call a server, needs to do and needs to provide in terms of parameters and information, and what the other end needs to do, right? And we combine the two. So for that particular, this particular instance is going to be based on, in this diagram, this particular name of a template. So what happens is the broker, right, and our product Paddy is a broker, so it does this, creates an instance based on this, because there is a client that can talk, that can be a client of this profile, and there is a server that can be that can talk this profile, right? So Paddy the broker says, okay, we'll create an instance, right? And what flows here between the client interface and the server instance interface is really metadata, right? We're not into the data yet. This is just sort of establishing the relationship between the client, whatever it is, and the server, whatever it is, right? So metadata about URIs, context, and other sort of information is really what this is about. The purpose of all of this is that each of these interfaces at either end is the kind of the dots that we were seeing earlier actually represent some real thing, right? Some real, this is an air conditioning unit, and the other end is some server somewhere, right? And what the metadata that's provided by the connection instance is pushed down to the subsystems, right? And the purpose of all of that is so that the subsystem, the client and server systems can then communicate across the internet using whatever protocol and whatever mechanism they want, right? So this separates the data plane from the control plane, which is really what's going on up the top. This is just to do with control, and the control not just sort of sets it up, but it sort of manages and monitors it over its life. So for example, if the server, the URL of the server may change 3 years after installation because there's some issue or whatever, right? A new server is installed. And in a normal situation, any integration will break, right? Because the client has no way of knowing that the server has changed unless we all humans go around and try and figure that out 3 years after the project was commissioned. Good luck with that. So what happens with a connection instance is that the server instantiates itself to the new server instantiates itself to the server interface and says, I've got a new URL, right? And so the broker then says to the client, your server has a new URL. The client knows about it instantly. So the moments later, if it needs to communicate, it will communicate using the correct URL. And obviously, this is not a one-to-one. The server could be connected to thousands of clients if they were devices. So it sort of automatically just sort of dynamically keep everything in sync, while maintaining the use of both existing and future as yet undefined protocols to go across here. It really doesn't matter what goes across here.
Right. So it is, in a way, also overcoming the problem of data drag, where something might change and we don't necessarily know the latest, most up-to-date information with our digital twin, because there is a delay or missing information coming from the metadata. So this, in a way, is overcoming one of those problems that has been alluded to a lot, actually.
Yes.
Okay, great.
So that's an introduction to connection profiles. And
Thank you. Yeah, it's a lot more understandable when you see it visually. So thank
that's
you for sharing this.
that's why I wanted to go down this path.
Brilliant.